Hello everyone, welcome back to our chemistry class. So this is the part B video for Le Chatelier principle, and in this video we will be talking about the first type of disturbance, changes in concentration. Okay, so let's say we have a reaction in which A will produce B. So changes in concentration can happen in two ways. The first one is increase in concentration, and then the second one is decrease in concentration. So increase in concentration can happen in both reactant and also product. Sama juga, decrease in concentration also can happen in both reactant and also product. And take note that changes in concentration can happen for gas and aqueous only. So mari kita tengok contoh yang pertama. Katakan kita ada satu persamaan A will produce B. So di dalam bikar itu dia ada 1 mol A dan 1 mol B, yang mana ianya berada dalam keadaan equilibrium. And then after that we increase the concentration of the reactant. So kalau kamu tengok ada 2 mol tambahan A di sana, so the equilibrium is disturbed. Okay, the equilibrium is disturbed. So what will happen? Net reaction will happen to reduce the disturbance. Therefore, okay, the reaction will shift to the right. Okay, the reaction will shift to the right to produce more product until the equilibrium is re-established. Okay, sama juga dengan contoh yang seterusnya. So kita ada equation A will produce B. Okay, so in that beaker A and B is in equilibrium, and then we increase the concentration of the product. So the equilibrium is being disturbed. So what will happen? This reaction will shift to the left and we will produce more reactant so that the equilibrium can be re-established. Next kita tengok pula, okay, sama juga kita ada equation A will produce B. So as we can see there, the system is in equilibrium, yang mana kita ada 3 mol A dan 3 mol B. Tapi kita decrease the concentration of the reactant, menyebabkan the chemical system is being disturbed. So what will happen? Net reaction will happen to reduce the disturbance, causing the system to shift to the left to produce more reactant. Okay, this will happen until the equilibrium is being re-established. And then the last example, sama juga kita ada A produce B. So in equilibrium, okay, we have 3 mol A and also 3 mol B, and then we will decrease the concentration of the product, causing the chemical system is disturbed. So net reaction will happen to reduce the effect of the disturbance, and it will shift to the right to produce more product until the equilibrium is being re-established. So mari kita tengok contoh di sini penghasilan amonia. Okay, so this is what we call as a chemical system. Okay, and the original equilibrium for this system is Q is equals to K, meaning to say the system is in equilibrium. And then disturbance is being introduced to the system by adding extra hydrogen. So bila kita tambah hydrogen, concentration of hydrogen will increase. Okay, and this will cause a disturbance in the system, causing the value of Q is not equal to K. So how can we reduce the disturbance? So we need to reduce the concentration of hydrogen by increase more production of ammonia. Therefore, the net reaction will shift to the right ataupun will proceed to the right until the equilibrium is re-established. Okay, daripada segi penerangan grafik di sana, kalau kamu lihat pada awalnya sistem berada dalam keadaan equilibrium, and then hydrogen is being added to the system, causing a disturbance happen. So net reaction will happen to reduce the disturbance. Okay, so concentration of hydrogen will decrease, concentration of nitrogen also decrease, and also concentration of ammonia will increase until the equilibrium is being re-established. For heterogeneous equilibria, the change of concentration also will give similar effect as in the homogeneous equilibria. Tapi kamu kena ingat, changes in concentration of pure liquid or solid does not give effect to the equilibrium position. So sebagai contohnya kita ada liquid di sana. Kalau kita kasih tingkat concentration of water, it will not shift the equilibrium position since it does not affect the equilibrium constant. So mari kita tengok beberapa contoh changes in concentration. So katalah kita ada sistem, chemical system yang ini. Okay, and then at equilibrium Q dia sama dengan K kan. So bila kita tambah Cl2, concentration of Cl2 will increase. Okay, so bila concentration Cl2 increase, what will happen to the value of Qc? So the value of Qc will decrease. Okay, jadi bila value Qc itu decrease, meaning to say Qc is less than Kc. Jadi kalau kita guna konsep Pac-Man, okay, kita lukis Pac-Man di sana dan kita dapat lihat bahawasanya anak panah akan menuju ke sebelah kanan. So meaning to say this reaction will shift to the right. Okay, so bila dia shift to the right, dia akan consume additional chlorine, itu menyebabkan concentration of PCl5 increase, concentration of PCl3 decrease. So kita boleh conclude, and the new equilibrium, concentration of PCl5 is higher than its original concentration. Chlorine punya concentration less than its original concentration, and PCl3 punya concentration pun less than its original concentration. So ini adalah data yang diambil daripada uji kaji sebenar di dalam makmal. So kalau kita boleh lihat sana, original equilibrium, and then new initial selepas chlorine is being added, and then new equilibrium bila dia sudah re-establish the equilibrium. So bila kita calculate value Kc for original equilibrium and also Kc at the new equilibrium, the value of Kc is still the same. So we can conclude that at a given temperature, Kc does not change with a change of concentration. So mari kita tengok another example of changes in concentration. So mula-mula at equilibrium dia Q sama dengan K, and then we remove the PCl3, meaning to say dia punya concentration of PCl3 will decrease. So bila concentration of PCl3 decrease, okay, what will happen to the Qc? So Qc will increase. So bila value Qc increase, meaning to say Qc is larger than Kc. Okay, so bila Qc larger than Kc, and bila kita lukis itu Pac-Man, so kita akan nampak equation ini, sistem ini dia akan shift to the left to reduce the disturbance. Okay, shift to the left. So bila shift to the left, more reactant will be produced. So the concentration of PCl3 and chlorine will increase, but the concentration of PCl5 will decrease. So, apa kata kamu buat example 1 ini, dan saya akan share jawapannya dengan kamu sebentar nanti. So, ini adalah jawapan untuk example 1. Enjoy guys. Next, kita tengok pula example 3. So, you are given the equilibrium constant for the reaction, which is 24, and the initial concentration for PCl3 and chlorine also given. Question A, you were asked to determine the concentration of species at equilibrium. So, sebab dia kasih kamu initial concentration dan dia minta kamu cari concentration of species at equilibrium, dan dia bagi kamu value Kc, maksudnya kamu kena solve question A guna ice table. So, kita list out dulu every information that are given from the question. And then we construct the ice table and fill in all the information that we list out just now. We are given the value of Kc which is equal to 24. So, kita express Kc berdasarkan equation yang diberikan. And then we ganti masuk all the value from the ice table that we construct. And we solve this equation and we treat it as the quadratic equation. So, from this equation, we will have two values of x, which is 0.97 and also 0.60. Jadi sebab kita ada dua value x, kita kena cuba ganti masuk kedua-dua value ini untuk cari concentration of each species in this equation. Oleh sebab kita dapat value negatif untuk concentration bagi x sama dengan 0.97, maka value x sama dengan 0.97 adalah rejected. So, kita cuba pula bikin untuk x2 sama dengan 0.60. Okay, so bila kita guna value x2 sama dengan 0.60, kita dapat concentration bagi setiap spesies dalam sebutan positif. So, kita boleh buat kesimpulan, therefore, at equilibrium, concentration for PCl3 is 0.2, Cl2 is 0.125 and PCl5 0.60. Next, untuk question B, so you were asked to find the concentration of each species at equilibrium if the system was disturbed with the addition of 0.075 of chlorine once the equilibrium is established. So, kamu kena faham soalan ini bagus-bagus. So, sistem tu dia dalam keadaan equilibrium, okay, and then it was disturbed. So, kamu kena cari concentration of species bila itu equilibrium is re-established. So, maksudnya sekarang kamu punya initial concentration itu, dia adalah sama dengan concentration of species at equilibrium yang kamu kira di dalam soalan A. You have to understand that. So this value you will use in the ICE table, okay, to answer question B. So basically kita repeat sahaja langkah kerja yang sama macam yang kita buat di dalam soalan A tadi. So ini adalah summary yang kita bincangkan di sepanjang video ini. So kamu boleh pilih untuk hafal ataupun guna kaedah Pacman untuk menentukan the shift in the equilibrium sama ada to the left or to the right. Okay, that's all for this video guys. Thank you for your time. Take care and have a nice day.